Hi guys, today we're learning about absolute value inequalities. Our learning target is I can solve inequalities involving absolute values. And so we're going to start off with a couple of review questions. So getting x by itself here in this first inequality, we'll add 7 to both sides. And we have 3x is greater than 18. Dividing both sides by 3. You get x is greater than 6. So there's our answer for that first one. For the second one, you'll notice it's a little bit different because we have absolute value here. And in general, your first order of business whenever you're dealing with absolute value stuff is to get the absolute value sign by itself first. So we're going to move the 7 to the other side first and get absolute value of 2x minus 1 is equal to 5. Now the question is, what do I do with that? So if you need a little bit of review about absolute value, here is its definition, and I would write this down. Definition is absolute value is the distance away from 0. So for example, if I've got something like the absolute value of x is equal to 5, it means what is the value of x such that it's 5 units away from 0. And it could be 5 units to the right or 5 units to the left. Or in other words, x could be positive 5 or negative 5 because both of those numbers are exactly 5 units away from 0. So going back to our previous example, we got to finish this guy out. We're looking at this absolute value right here is going to be 5 units away from 0, so it could go left or right. So we're going to start off with the left. 2x minus 1 is equal to negative 5. That's the left side. Or 5 units to the right puts us at positive 5, so 2x minus 1 could be equal to positive 5. And then we're going to work to solve this by adding 1 to both sides. And the nice thing is with these equations, you'll basically be doing the same steps twice. And so if you do negative 5 plus 1, you get negative 4. Dividing both sides by 2, you get x could be negative 2. Or you want to bring that or down. Or solving this guy with the same exact steps, adding 1, then dividing by 2, we get 2x is equal to 6, divide by 2, x's could be 3. So there's our answers for that guy. Okay, and that 3 did not get quite connected there, but it's positive 3. So that's our answer there. X could be negative 2 or positive 3. And so what we're going to do now is talk about what happens when we get absolute value, not equations like this guy with the equal sign, but inequalities with less than or greater than situations. And we're going to be using the idea of separating an absolute value into 2 separate equations for all of this stuff. So one example we might consider is the absolute value of x is less than 5, okay, and we want to graph the solution on a number line. So the question is that I really want you to focus on when you see a question like this is what values of x are less than 5 units away from 0, because remember absolute value is all about distance. And so we could consider things like x could be 4, x could be 2, x could be negative 3. All those things are less than 5 units away. And if we graph this on a number line, here's 0. 5 units away to the right puts us at positive 5. 5 units to the left puts us at negative 5. We were going to talk about all the numbers in between those two things. And remember, we're not including 5 and negative 5, but we can get really, really close. So you want to use those open circles to indicate that we don't actually include them, but we are getting butted up right against them. So we're going to be shading all the numbers between 5 and negative 5, but not including them. Now going on, we can see this with another example. If we've got something like the absolute value of x is less than 3, you're going to start off with your number line. And we have 0 here, and positive 3 on the right, negative 3 on the left. You are going to look at all the numbers in between the right and the left number. And so we're going to be shading between negative 3 and positive 3. And so that is the situation we've got there, and that's actually our answer. Now, sometimes you'll have something a little more complicated, and again, the idea is get absolute value stuff by itself first. So if you've got to move something, make sure you do it. Graph your number line. Put 0 in the middle, the positive on the right, the negative on the left, And since this is less than, we want to talk about all the stuff that is closer to 0 than our end point. So we're looking at all those numbers between 7 and -7. So the question is, what do you notice about the examples we've done so far? Well, if you look at these examples here, we have less than here and less than here. They've all been less than situations. So the question is, what do you do when it is a greater than situation? So for example, if I've got absolute value of x is greater than 5, well, this means that I'm asking for values of x that are more than 5 units away from 0. So graphing this on the number line, if I put 0 in the middle, and I'll put 5 over on the right here, that's 5 units away, and then -5 over here, that's also 5 units away. I want the numbers that are further away than each one of these end numbers. So we're not going to include them because we want numbers that are just greater than, not equal to. And if I want numbers that are more than 5 units away on the right, that makes me go more right. And if I want numbers that are further away from 0 on the left, that makes me go more left. So I'll be shading everything on the right here. Make sure you include arrows, and on the left there. So it's a very different type of graph that we'll be dealing with greater than. But they will kind of look like that for absolute value situations. So here's another example. Let's say if I have the absolute value of x is greater than 3. That means I want numbers that are more than 3 units away from 0. So here's +3 on the right. Here's -3 on the left. We are going to not include them, so open circles there and there. And remember, we want to go more right and more left, okay, because these are further away than 3 units. With the next one, again, you might have to get absolute value by itself first. So I'll add 2 to both sides and get absolute value of x is greater than 7. And on my number line, here's 0, here's 7, and here's -7. Remember, these are not drawn to scale. And we don't want to include 7 or -7, so we'll put circles there. Going more right and more left takes me out further, more than 7 units away from 0. Now, we obviously don't always get easy questions. So here's a harder one. If we're solving absolute value inequalities. Now I wrote this out to you, and I really think it's a good idea to write it down in your notes also. If you see greater than, separate with or. You want to do less than negative, greater than positive. Okay, so again, first step is always get absolute value stuff by itself first. So we'll move all the numbers that are not absolute value. And we'll do this. Going ahead is going to be greater than 38. And then we're going to divide it by 2 to get the absolute value of 3x plus 4 is going to be greater than 19. And so what we're dealing with now is we got to figure out how to handle this. So what you're going to do, and we're not graphing, is you're going to say what's inside, okay, 3x plus 4 is less than the -19, or, because you have to separate with an or, that's what I said here, separate with or less than negative, greater than positive. So we'll take what's inside this 3x plus 4 and say that is greater than +19, and then just solve these guys. So we'll just get x by itself. If I'm going too fast, be sure to pause the video and catch up a little bit. And divided by 3. Don't forget to bring down the or. You're going to have, I'm going to go a little bit further down. You're going to have x is less than -23/3. Or, and then solving this guy, again, same exact steps. So that's the nice thing about absolute value stuff, is you do basically the same thing twice. You're going to get 15 here, divide by 3, and x is greater than 5. So there's our answer for that situation. I'm just going to erase this guy because it's driving me crazy. With the next example, we'll see we're dealing with not greater than, but less than. So I wrote this down, and again, I really recommend that you write it too. If less than, set inside in between the negative and positive. So again, get absolute value by itself first by doing what you must. We get the absolute value of 3x is less than 13. Now what's going to happen here is you're going to put the inside, this 3x, in between negative on the left. Oops, let me try that again. Negative on the left. Right. Thank you. And positive on the right. And then we're going to work to get x by itself. So again, whatever you do to the middle, do to everything. Cancels those threes. We have negative 13 thirds is less than x is less than 13 thirds. Okay. So there's our answer for that particular situation. Now, here's a slightly harder question, and I always recommend, again, getting absolute value by itself first, and then also simplifying what you can inside the absolute value sign. So I'm going to go ahead and do what I do first. Sound effects make everything better. And we're going to say is greater than or equal to 16, dividing both sides by 2. And we get the absolute value of 3 times x minus 2 plus 4 is greater than or equal to 8. Now what we want to do here is simplify what's inside the absolute value sign. So I'm going to distribute the 3 and do a little simplification. I'm going to combine some like terms. Trust me, you will get 3x minus 6 plus 4 is actually going to get you minus 2. And that is going to be greater than or equal to 8. Okay, now this is a greater than situation. So again, you're going to say what's inside is going to be, we have 3x minus 2. It's going to be less than the negative or the inside. Let me erase that. Or the inside, 3x minus 2 is going to be greater than the positive, and that's always what you want to deal with here. So we have 3x minus 2 is less than negative 8, and 3x minus 2 is greater than positive 8. So we're going to solve this thing. So I'm going to add 2 to both sides, and I'm going to do that for everything. 3x is less than negative 6, dividing both sides by 3. X is going to be less than negative 2, or, don't forget to bring down the or, and then same thing, add 2, 3x is greater than 10, divide both sides by 3, and x is going to be greater than 10 thirds. That's our other possibility here, okay? And you can graph these things if you need to, but you really shouldn't have to unless it tells you to. So another example, same idea here. We're going to be solving this guy, and I believe this is pretty much the last example. Yep, it sure is. So that's good. We'll work through this real quick. Add 8 first. 3, 2x minus 5 plus 4x. Whoops, don't need that. It's not parentheses. It is a absolute value sign, is less than or equal to 13 plus 8 is 21. Dividing everything by 3. These 3's cancel. I have the absolute value of 2 parentheses x minus 5 plus 4x is less than or equal to 7. I'm going to simplify what's inside the absolute value brackets real quick. So I have 2x plus 4x makes 6x minus 10 inside. It's going to be less than or equal to 7. Okay, so we're going to take what's inside. This is a less than situation. So we take what's inside and set it between the negative and the positive. So I'm going to say negative 7 is less than or equal to 6x minus 10. And is less than or equal to positive 7. Adding 10 to all sides. Let's do this, 10, 10, 10. And we get 3 is less than or equal to 6x is less than or equal to 17. Divide everything by 6. And we get our final answer of 1/2 is less than or equal to x is less than or equal to 17 over 6. And that is our answer.